In lesson 6.7, we're going to be talking about arc length, which has to do with the distance around the perimeter or the circumference of a circle. And as we look at this clock, since we know that the arc length on a circle is equal to the central angle that intercepts it, we can talk about the arc length, for example, or measurement, I should say, from the two hands creating the 1 o'clock position, would be this arc length here from 12 to 1. And since we know that the total number of degrees in a circle is 360 degrees, what we want to do is we want to take 1/12 of that 360 degrees. Or in other words, we're dividing the 360 by 12. And so we know that this highlighted green arc length would be 30 degrees, because 1/12 of the distance around the outside of the circle in degrees would be 1/12 of 360, which is 30 degrees. To find out the length, if we were talking about measurement in feet, meters, inches, that kind of thing, we're going to use the same principle. On this next slide, what you'll see is an arc AC. And we know that the arc AC is going to be 90 degrees. And the reason that we know that it's 90 degrees is because inside the triangle, or inside the circle, pardon me, you'll notice that we have a right angle formed by the two radii BA and BC. And 90 degrees is 1/4 of the way around the circle. So 1/4 of the way around a total of 360 degrees is saying the same as 1/4 times 360, or in other words, 90 degrees. So we actually have two different ways to know that the arc measurement in degrees is 90. We could say that we know that because of the central angle is 90 degrees and it's the same as the arc in degrees, or we could understand that the arc is 1/4 of the way around the circle, the circumference that is, and so 90 out of the 360 is 1/4 of the way around, and that's why it's 90 degrees. Now, let's say in this same example that we told you that the radius of the circle actually had the measurement of 12. So if I know that the radius is 12, then normally, if we're talking about a circumference, we would be talking about the distance around the circle. So we would say, in this particular circle over here, that the circumference would be equal to 2 times pi times the radius, or in this case, 2 times pi times the length of the radius, which is 12. But this information, which we also see below here, 2 pi times 12, which is the circumference of the whole circle, if I went all the way around, this would be the distance around the circle in purple. We also know that since we have 90 degrees, what I should be doing really is I should be taking this measurement over here, and I should be taking whatever fraction of the circle it is. And we know that it's 90 degrees out of the 360 degrees, or in other words, this is 1/4 of the way around the circle. And what you'll see is in this problem, we multiply by 1/4, because really all I really wanted was the length of the arc that was on the 90 degree section. So first I'll find the whole distance around the circle, find the circumference, that's in the purple, and then what I'll do is if I only want a part of that circumference, I will multiply by the ratio that would give me the part of the circle that I'm talking about. In this case, that ratio is 1/4 because I have 90 degrees out of the total of 360. Let's take a look at another example. Here we see an inscribed angle. And in this inscribed angle, we notice that we have a 60-degree inscribed angle. That tells me that if I'm looking at the arc over here in orange from R to D, since the inscribed angle is half of the arc it intercepts, I know that the degree measurement for R to D is going to be 120 degrees. Now, if I also told you, for example, that in this case, the radius was a 8-inch measurement, we could talk about the circumference of this circle. So let's say we're talking about the circumference of this circle, and I want to see how far it is all the way around. The way that I would do that, of course, is I know that the circumference is equal to 2 times pi times the radius. So in this case, after I tell you that the radius is 8 inches, I would tell you that this would be 2 times pi times the radius of 8, which is, if you multiply the 8 and 2 together, 16 times pi. And since I'm going around in inches, I would say inches, of course. But if I don't care about just the circumference, and really what I'm interested in is just this orange arc part of the whole circle, obviously that measurement is smaller than 16 times pi inches, which is somewhere maybe around 50 inches. So what I would do is I would take that circumference and I would multiply by the part of the circle that I would have. And so this actual amount here is not 90, this should be 120 degrees out of the total. So I'm going to take the proportion of the circle that I want, which in this case is 120 out of the 360 degrees, and I multiply that by my circumference, which we earlier found to be 16 pi. Now, when I figure that out, what I figure out is that, I'm going to cross off all this stuff actually since I'm doing the problem for you, so please ignore all that information. I figure out that since I have 120 degrees, then what I'm going to do is I'm going to take that measurement ratio of 1/3, 120 degrees out of the 360, and multiply it by my 16 pi. If I leave this as an improper fraction, my final answer would be 16/3 pi inches, whatever that came out to be. So 16 pi we said was somewhere around 50, so in approximations that would be somewhere around 17 inches, which makes sense because if all the way around it's about 50, which is pretty close to 51, 1/3 of 51 would be 17 inches. So you can type that into your calculator and give a 2 decimal approximation, or you can just leave the pi there if you like. And again, there was an error on this slide, I believe. This 90 should have been 120 out of the 360 instead of the 90 that was marked there. My apologies. So another example, the big idea here is we know how to find circumference, so you find the circumference, and then find out the arc in degrees, divide that by 360, and whatever ratio it is that you get, like in this case 1/3 in the orange, then you multiply that by the circumference to find the actual arc length that you're curious about, which in our case here was the orange arc length that we were talking about. So in general, the length of an arc is equal to the circumference times the measure of the central angle divided by 360. And the big idea, of course, is always find that circumference first. Here you'll see that circumference highlighted in green. And then take the central angle, divide that by 360, and you'll have your answer. So any arc length, and I'm going to add the word arc here, any arc length is the circumference of a circle times the central angle measurement divided by 360. Looking back at the previous example, what that meant is I took the circumference of 16 pi and I multiplied that by 120, which was the central angle measurement, and then divided by 360. I know that 120 was the central angle measurement because an inscribed angle is half of the arc, but the central angle is the same as the arc. So if I were to extend another radius, cutting off the orange arc, I would see that total of 120 degrees inside of the central angle. One last time, big idea, arc length is the circumference times the central angle divided by 360 degrees.